where Paul Marrow is going to tell us about, well, what nothing plus nothing equals, maybe, or much ado about nothing.
Okay, yes, I would like to talk to you about nothing. This doesn't mean that you can go to sleep for the next 5 minutes. Well, you can if you want. But actually, nothing is more complicated than the number nothing, even though there's been much ado said about it. For instance, Mr. William Shakespeare wrote this play, Much Ado About Nothing, which is actually not about nothing. Unfortunately, I know almost nothing about it, so I'm not going to say anything about it. But I have heard it's received a lot of critical acclaim. You may have heard of this, but you will not have heard it, because this is a musical composition in which musicians do not perform. So there is zero sound. Unfortunately, there's limited time to perform this, but a long time in the past, the ancients thought about the concept of zero or nothing. The ancient Egyptians had a word for it, and they thought it was good. The ancient Babylonians had numbers, but they didn't have a number for nothing. They had a space. The Greeks had big philosophical problems. The Romans didn't have a number, they had a letter. It took a long time for nothing as zero to come into English via a complex route. But even by the 19th century, so-called natural philosophers had problems with it. But now we do have nothing. It's a natural or whole number. We can use it for counting. We can use it for putting things in order. It's an even number as well, oddly enough, despite being nothing. But it's also a real number. This means it's a decimal or fraction, and you can place it on a number line, an infinite continuum of numbers, where it sits somewhere along that. The problem with zero as a real number is it becomes much more complicated. Here we have zero and one of its friends, 1. If we're talking about them as whole numbers, that line in the middle is completely empty. But if they're real numbers, there's lots of other numbers in the middle there, and we don't know how many there are. There's really lots and lots of them. So we have to say hello to infinity, because that's how you say lots and lots of numbers. This is how various programming languages deal with infinity, but they're all approximations, because in a programming language, you can't deal with infinity properly. So how big is infinity? Consider a drink you've got from the bar. In a whole number, this is one drink. If you had lots of different ways to measure what's in it, you might say there's an infinite number of constituents to this drink, although that would be inaccurate. But if you drunk that drink up, you might say, now I have 0 drinks from the bar, or you might say that's a very small number. But if you're measuring that on the real number line, you might say there's an infinite number of ways of measuring what's in that nearly empty glass. What you really need is a mathematician like Georg Cantor, a German mathematician who studied this issue at great length and became a master of infinity. And he thought, how do you actually count infinity? Or how do you count numbers? If you think about natural or whole numbers, you can count them, and you start off with finite numbers, but eventually they become infinite. So you need a transfinite number, and this number, Aleph null, is how many whole numbers there are. Real numbers are more difficult because you can't count them in the same way, because there's an infinite number of infinities. You need another kind of transfinite number, fractor C, or Aleph eins, which is much, much bigger than Aleph 1. When this ideas came out, eminent mathematicians and philosophers were really annoyed about this, and here are some of them, and this is what they said about it. But they were wrong, because it works very well in modern mathematics, and it's established the basis of set theory, it's established the basis of applied mathematics, it's created things like the empty set, a set that contains no thing, not 0, but it is completely empty. And from that, it's been used for useful things like putting 0 with 1, creating the binary system, and developing software, making portable software like this software that Margaret Hamilton had to drive the Apollo 11 lunar lander. Another thing that the binary system has suggested might be useful for is for the Internet of Things. This is not my vision of the Internet of Things. This is somebody else's vision. But the Internet of Things is still developing, and software is part of it. It's also good for developing new career directions that might not have otherwise existed. And Liverpool Girl Geeks is an organization here in Liverpool which helps to train girls and women in software development and in directions they might not have thought of. And here is another transfinite number, Beth null, which I won't have time to talk about because time is tending to 0 and this talk is tending to its end.
You know